Hello, this is Lab 4 Circuits by Hiley. So, this lab, the introduction. The purpose of this lab is to investigate the behavior of direct current circuits, and by analyzing these circuits with resistors that are both series and parallel, we can measure current and voltage. And some fundamental principles that are used are Kirchhoff's laws, Ohm's law, and the RC time constant. So the results of this experiment were that the measured circuits matched Kirchhoff's current law, and it also matches Kirchhoff's voltage law. And another thing that matched was that the RC circuit time constant was very close to the expected value. And some assumptions that we used are that the resistors follow Ohm's law and the circuits were ideal. So part 1 of the experiment, it included 2 batteries and 2 resistors. And we expected the current to be around 0.202 amps. And for the first resistor, the one on top, which was 47 ohms, we expected the voltage to be around 0.96. And for the bottom one, which was 100 ohms, the voltage was expected to be 2.04. And when you add both those voltages together, you get 3 volts. And the potential difference at each one of these points, so it drops whenever it occurs when it passes through a resistor. So here you see the drop, and the drop is higher for the resistor with the most voltage. And it starts at 0 volts and also ends at 0 volts because of the voltage law. And for the next part of the experiment, you have you put it in parallel instead of series. And if you do this, the resistors will stay the same value of 47 ohms and 100 ohms, and the resistance of the wire and ammeter will be 0 because we are doing the experiment in an ideal circuit with ideal materials. For part 2, which included a 10 ohm bulb, a 20 ohm bulb, battery, and a capacitor, the results of plotting the log of voltage over the initial voltage will get you this graph, and this is what the setup looks like. And for the system of this experiment, it's the whole RC circuit, while surroundings is everything else, which isn't much because we're doing it online. And by plotting this graph, we can get the time constant by doing 1 over slope, which gets room for 5.99, or basically 6 seconds, while the expected time constant, you can get from multiplying resistance and capacitance, which would get you 6 seconds. So both of these times are extremely similar. And some sources of error, basically no error, because we're using an online model from PHYS, and everything is ideal, and there should be very little places for error. And some questions to that are going to be answered are, if we were doing this lab in real life and used an actual ammeter instead of a simulated ammeter, what would change is that its internal resistance, even though it's not too big, it's going to affect the total resistance of the circuit. And this is going to cause a minor decrease in the current and is create a small voltage drop across the ammeter. And this didn't happen in the virtual circuit because the ammeter is ideal. So the values would be higher in the virtual circuit than in a real circuit. And the last question is, what if we were doing this lab in real life and we used an actual battery to charge a real capacitor with no resistor? And when you're charging a real capacitor with no resistor, the ideal model predicts that the capacitor would charge instantly since there's no resistance at all. But in reality, the battery and the wires have some internal resistance, and this prevents infinite current, and it causes the capacitor to charge a lot quicker and not instantly. So measuring the charging time would show a near instant charge that's a little lower than the ideal charge due to unavoidable resistance.